Hello everyone, welcome to the October JSE webinar. I'm Lee Harrell-Williams. I'm an associate editor for the journal Statistics Education, and we have a special lineup today. We actually have two presentations. So the way this will work is we'll have Stanley Taylor and Amy Mickel talking about their Simpson's paradox paper in JSE, in a recent issue of JSE. They'll talk for about 20 minutes. We'll have about 5 minutes question and answer. You can raise your hand. At the end, anytime during the session, you're welcome to type in questions in the question box, and I can ask you ask those to the presenters at the end of their talk. And then about half an hour into the presentation time, we will switch over to Eiki Satake and talking about an application of Bayes' rule, and then we'll sort of follow the same process. He'll talk for about 20 minutes, and then we'll do about 5 minutes question and answer. So I'm going to go ahead and hand it over to Stan Taylor and Amy Mickel.
Well, thank you very much. We appreciate the opportunity to talk to you about our paper. And as you can see there, the title was Simpson's Paradox, and we have a data set, and we discussed a discrimination case. And this is an exercise that we have conducted numerous times in our class, and give you a little bit of background with regards to the process. You see the different bullets that we have on the slides there. Both Dr. Mickel and myself, we have served as consultants to the California Department of Developmental Services I've done it the past 20 years, and Amy's been with it for the last 10 to 15 years. And our primary purpose on our consulting activities has focused around the idea of forecasting. We have helped forecast the financial needs for the Department of Developmental Services. And you can see there that the Department of Developmental Services oversees the allocation to over 250 developmentally disabled individuals. We call them consumers, and these are individuals who have disabilities due to cerebral palsy, epilepsy, they might be mental retardation, and in recent times a big category has been that of autism. Autism has been growing at about 20 to 25% per year, and it's really expanded the cost structure. Now, that's just giving you a little bit of background of how we interacted with the Department of Developmental Services. A number of years back, a few years back I should say, there was an individual who had worked in the Department of Developmental Services for over 30 years. He had been retired. He came back as a special consultant himself, and in the course of his activities he undertook a univariate analysis where he was looking at some of the summary statistics, and one thing that really stood out was that white, and we'll define right now as white non-Hispanics for technical reasons, and also their expenditures that they received. Now keep in mind that when we talk about expenditures in our case study, we're talking about the amount that individuals actually receive from the state of California. And when we talk about the consumers, a lot of times it's just not the consumers, but it's their family that receive the funds, because these individuals sometimes are unable to account for it. They could be children, or they could be such that they're so dysfunctional that they are unable to manage their own affairs. So what stood out, again, going back to the analysis that was done by the retired consultant coming back, was that white non-Hispanics were receiving far more than Hispanics. In fact, the actual numbers were about a 3-to-1 ratio. Now, this is particularly alarming due to the fact that the possibility of discrimination popped up, and the agency that we're working with was very concerned about were they possibly committing a case of discrimination, and so his findings went up to management within the State Department that we work with, and went up further than that too. It went up to the legislative branch within the state of California, where the Speaker of the House and some other of the top-ranking officials are all Hispanic, and therefore there is very much of a concern of if there was going to be a situation of discrimination. Now, we've worked with the agency for a number of years, and therefore we thought that we might be able to give some insight, and we were brought on board to particularly answer the question, or help them, I should say, determine if discrimination actually was indeed something they should be concerned about. And in the course of doing so, knowing some of the background, one of the things that came into account that was very important to consider was age, and we'll talk that a bit more as we go through the case in just a few minutes. But what we encountered here was a classic case of Simpson's paradox, and in particular, it was very hard for management and some of the people in the legislative branch to understand that we had this situation where the univariate analysis said there was discrimination, but then from a statistical point of view, we came back and said there was not. And so that was really the motivation of coming up with the case in the first place, was trying to prepare our students down the road to understand the idea of how they should go about interpreting such situations. You can see here where we have the case objectives, and I'll let you go ahead and read through that. But in the course of doing so, let me point out a couple of things. The course in which this case is presented is a second-level business statistics course. It's a course in which the students have already been introduced to their introductory to statistics, and they've gone through as far as doing hypothesis testing. And what we wanted to do was to go ahead and try to make sure that when we have our students complete their course of studies, that they're prepared to try to be effective managers. And as I tell my students, when trying to determine what is an effective manager, being able to interpret the information, I think it's very important that they are able to understand the, as I like saying, the big picture of how things fit into place, and really knowing the important questions to ask so that they can do an appropriate analysis. So going back and filling in some of the gaps right here, we really talk a lot about the idea of specific variation versus common variation in our course, and this is delved in further in a paper that I co-authored with some of my other colleagues in the Journal of Statistics Education a few years back. So we did a big emphasis on, as I said, specific variation. There are outliers in our data set, which we'll talk about. And again, the key aspects would be the idea of a univariate versus bivariate analysis and how you can get the different interpretations, and hence Simpson's paradox. In the course of doing so, we also wanted to try and enhance the students' analytical critical thinking skills, and that is think of the big picture and how to go about making proper interpretations. Talk about the data set that's available with the case. Again, there were 250,000 individuals within the database that the state of California has for the Department of Developmental Services. It's called the CEDAR file. What we have here is a restriction of that data file for confidentiality reasons, but we did put in some identification codes that would be similar to a social security number that they use, and also we have 4 other variables that are actually used in the analysis. Interesting, some students try to do analysis on the identification codes, which later on we tell them doesn't make any sense, but the variables that do possibly make sense are age cohort and age. So we have provided, in this case, 2 different variables associated with age. The first one is the age cohorts, which are 0 to 5, and that corresponds to to individuals in the pre-school age. 6 to 12, which would be elementary school. 13 to 17, going into high school. 18 to 21, which we call the transition group. Then you have the 22 to 50, and this is where individuals are moving out on their own. As you'll see, they become more expensive at this time because there's supported living that needs to go into place. And also the 51 plus group. And these are individuals that tend to be even more costly due to the fact that their support system with their parents are no longer available, so it would be more expensive. We also have age unbind, which is available for somebody if they want to do other analysis. But we try to stress to students that you have the age cohorts and talk about the life cycle that goes along with that and how, as they go through, they tend to be more expensive. The gender, male, female, is pretty self-explanatory. Expenditures we've already talked about. That's the annual amounts that are spent on each consumer. So discrimination would occur if an individual was receiving less than would be the case for others. Ethnicity, we have 8 categories that the state of California uses. And with regards to the instructions, then the tools that we use in the course, we talked to the students about the idea of trying to make sure that they, in examining discrimination, we talked about the definition being, as you can see, if the typical person in one group receives significantly less than the person in another group, then we might be able to say that there's discrimination. With regards to tools that we use, you can use numerous software packages. One might use R, you can use SPSS, one might use Minitab, maybe SAS. We chose to use Excel, particularly because we want to go ahead and incorporate pivot tables into our curriculum. We've had a number of large firms on here who want to have students with that background, so that's why we chose it, although it's not necessary to complete the case. Looking at the results of the data, one can see that in this situation that if one were to look at by strictly ethnicity, one will note that there's a large variance among the numbers. And when we do this with students, one thing that really pops out to people, they claim right away, there's obvious discrimination. You have Native Hawaiians with 42,000, American Indian 36, and then they have the other groups. Well, one thing we point out to them, and I forgot to include this in the slides, but also the sample sizes. The ones with the real large values, the outliers in this case, the Native Hawaiian, the American Indians, and the other, on the opposite end, those are groups that have very, very small sample sizes. So, in talking about discrimination, we've kind of talked about the 4 major groups that we have here, the 4 largest ones, I should say. And that was the white non-Hispanic, the Asian, the black, and also the Hispanic. And to take a look at with regards to gender, one can see that there's not really much difference at all, so we kind of dismiss gender as a possible source of discrimination. We talked about age. Now, we mentioned to our students that age is obviously in this situation a variable that is justifiable in that as one gets older, there tends to be larger expenditures. The reason for that is the younger age groups, a lot of times the services are picked up by the schools, so it's shared in terms of their support. But as one gets older, the needs increase, so that as, particularly if you notice there's a big gap between 18 and 21 where they're transitioning suddenly 22 to 50, and that's where people are going out and reciting on their own, so they need additional support, not just in terms of financing their residency, but also in terms of managing their funds, etc. So bottom line, as one gets older, the needs increase. So we talk to the students that this is not a basis for discrimination. However, it is a variable that can be used in terms of trying to explain the differences, particularly with regards to ethnicity. So if you take a look before we go on, you can see summarizing back before, we had the white non-Hispanics as the largest group and the Hispanics. And you can see we have that in bold font right now because those are the 2 extremes, the 2 largest groups that we had, but also the 2 extremes, the largest and smallest among the 4 larger categories. So what we're going to do is we have our students restrict their analysis to just basically the white non-Hispanics and the Hispanics. Obviously, I tried to say in class to be politically correct that we're not saying the other groups are not important, which they are, but they are of small sample sizes, and hence we're not going to consider them in our analysis. We're just trying to simplify the analysis for students so that they can get the picture of why Simpson's paradox occurred within this data set. Now, take a look at a bivariate display. You can see that on the left-hand column we have the age cohorts, and then we have the expenditures compared to Hispanics versus white non-Hispanics. So in this particular instance, it's interesting if you do a pairwise comparison for each of the individual age cohorts. you'll notice that actually the Hispanics are larger overall, with the exception of the 22, I'm sorry, with the exception of the 18 and 21 age group. Besides that, every age group you have the Hispanics receiving more than is the case for the white non-Hispanics. However, overall, the average for all Hispanics is 11,066, which is very much over half reduced from the white non-Hispanics. So the question we ask the students is, how could this possibly come about? And we really wanted to point out the fact that in this case, the Simpson's paradox is occurring, but when we talk to students, we say, if you just look at the values, the 11,000, the 24,000, obviously it seems like discrimination does exist. But if one were to ask a question of an individual, say they are Hispanic, and they're claiming that discrimination existed, and the discrimination because Hispanics got 11,000 compared to 24, the follow-up question might be, what age group do you belong to? And therefore, going down to the age cohorts, one would see that, wow, there's not much difference at all based upon the age cohort. So again, we ask the students the question, how could this possibly come about? Well, the answer in this particular case involves looking at the, again, if you look to the next slide, I'm sorry, before we go on, this is where you can take a look and see that the similarities for each age group in terms of the split between the white and the Hispanic groups, similarities. But going down, the answer to how Simpson's paradox comes into play here is with regards to the age cohorts and the percentages, i.e. the weights that we have for the average overall. In particular, one will note by looking at the breakdown that Hispanics tend to be a much younger population as compared to the white non-Hispanics. The whites tend to be a much older age group as indicated by their percentages. So if you look at the 0 to 5 group, Hispanics is 12% for Hispanic, 5% for white non-Hispanic, and you go up to the other extremes, 22 to 50, you have 33% being the white non-Hispanic group versus 11% in the Hispanic group. So again, the big picture here we're trying to portray to the students is that the Hispanic population tends to be their profile a much younger group than, say, that of the white non-Hispanic group. So in this particular case, we include the weighted average formula for its students, and the weights, of course, were the percentages according to the profiles that we have. And even by putting this formula up, a lot of our students have difficulty understanding the concept of a weighted average. So that's another objective in our analysis. So we actually have them take and get each of the averages from the age cohorts associated by the percentages, i.e. their weights, and we actually have them go through and do by hand the calculation. Again, students still have a little bit of problems. It really sinks in with this, the idea of weighted average, when I have them do the same thing for their grades. They tend to be much more involved with that calculation, and when I tell them that, for example, the final is twice all the other exams, then it kind of sinks in as to what's going on with the idea of a weighted average. So, in this particular case, then, just sort of making some concluding remarks here, this is a case where we try to really focus on a topic that's really relevant in today's environment, and that is discrimination. Originally, we thought discrimination, when I say we, the department, thought discrimination may exist with regards to the data they had based upon the univariate analysis that was done by an individual who had been in the department for many years. And then when we explained the concept, it was difficult for that individual, as was the case for a number of other people in middle management and in the legislative bodies, to understand how you could have such a disparity between the overall averages being so different. However, the individuals coming to the conclusion that there was not discrimination. And in the course of doing our analysis, we've talked about specific variation, and particularly I tried to focus on an idea for students. As I said before, I've tried to orient my course with regards to the concept of variation and trying to emphasize to the different students that what's really important is always to consider all possible sources of variation when doing analysis and how you get misleading results if you don't do that. Hence, the need to not just consider univariate analysis, but bivariate and anything going beyond that to more dimensions if necessary. The concept of a weighted average was brought forth in terms of the weights being associated with the percentages for each of the individual age cohorts. And when we figure out the overall mean, and of course, as we said before, this is a classic case of Simpson's paradox. And it's very important that people understand how you can get these different type of interpretations. And as we said, we did the analytical and critical thinking. We want to try to focus for our students on always thinking of the big picture. And really, in order to be an effective manager, we would like our students to be able to ask the questions always, is there a source of variation that has not been considered? And that is, have all sources of variation been considered when doing the analysis? And hopefully also our students walk away understanding how you can look at data from different views, and if you take different views of data, you may see different ideas emerge. And with that, that kind of concludes our presentation.
Thank you. That was a really interesting presentation, and it brought up a lot of ideas that maybe aren't necessarily emphasized in every statistics class. But one question that always gets asked about when you're talking about introducing these statistical concepts or a different statistical concept is the question of assessment. And so that's actually our first question from our audience is, how do you assess the student learning?
We've gone through and actually have our exam questions where we ask the students to give us an illustration of what occurred within this particular case, and also we ask them to give us an examples of other situations where they think such a application may in fact occur. So it comes more with regards to the exams when we address the issue at that time. And also it's important to realize, I didn't mention before, but one of the things that we have the students do is write a write-up of this, because we feel it's very important that in terms of doing statistical analysis, that students realize that you can do a tremendous analysis, but unless anybody can understand what it is that you've done, it's not very meaningful. So therefore, we have the students go ahead and prepare their write-up in this case, and give them a limit of 2 pages in which they do their write-up. And for the reason being, I want them to get in the habit of trying to write things very concisely and explaining the situation. So in the write-up of this assignment, students are required to provide a 2-page maximum write-up where they include different graphs and charts and figures. And as I said, trying to get them to do a very concise executive type format in terms of the write-up.
Okay. We've had 2 questions about the availability of the actual data. Is there something that you have de-identified and available for public use, or?
Yeah, we've taken and gotten a snapshot of the data. We can't give out all 250,000 records for purposes that the state wouldn't allow us to do so. And then we took some of the private information and just dummied in ID codes on the side. But again, we can't provide any of the information that might be private. But there is associated with the paper, the sample size was 1,000 individuals. That was used as an illustration of, that was extracted, I should say, from the data set. So you can think about it's kind of like a stratified sample in many ways, in that we had, when we took the idea of samples, we needed the idea of trying to get the profiles of the individuals within the state. So if you looked at the split up of the different ethnic categories, we tend to pull out the values when we sampled to reflect that. So what I'm getting at is, for instance, 40% of the state of California is white non-Hispanic category, and that was basically the size that we have from the sample in the data set also.
And just to kind of follow along that, in this edition, it was published in it's in 2014, the first issue in 2014, and the very last, close to the last page in the appendix, which would be on page 17, you are able to go to the data set, and it's in both it's in a comma separated value Excel file.
Great. The availability of that data set is great. A couple of comments here. One is sort of a praise about your presentation of the data, that you kept it sort of simple and didn't confuse it by introducing concepts like chi-square tests and p-values, and you really made it more about the bivariate analysis versus trying to do some sort of more formal hypothesis testing. There was a question about slide 10, and it said, would it have been useful to have the students compute two types of averages from the data on slide 10?
Yeah, actually, one could take a look at, because the question is whether the typical person in one age group versus the typical person in another age group receive differences. So, yeah, I could see where a good discussion might be in terms of teaching in this case, in terms of looking at the median values as opposed to the mean. We chose to just use the mean because that was one of the values you could get from the pivot tables. And that's a restriction of using the pivot tables as opposed to using some of the other software packages out there. But again, we were trying to accomplish a few different things at the same time, and so we restricted the pivot tables, but I could see where somebody might look at this and actually the analysis that we did in terms of consulting for the agency, we incorporate medians in values too. It's more maybe typical of the median of the typical values. So that's a very good comment.
Right. So actually, they were talking about using a simple average and a weighted average. I didn't quite get through all that question, but I think it's sort of along the same lines that you could. There are different things that you could do for data presentation and data comparisons. So I want to thank you both for presenting about the data set and the analysis you did with the students, as well as sharing the sample data set so that others may use it. And we're going to go ahead and start to segue into our second speaker for our hour session today.